In this problem, we have this 18 kilogram wheel initially at rest, and then it starts rolling without slipping under this constant force 300 Newton that is applied through the handle to the point G, which is the center of gravity for this wheel. This wheel also has radius of gyration kg, also about point G, that is 0.3 meter, and we need to determine its angular velocity after 2 seconds. So this is a problem that can be solved using equations of motion and kinematics. However, because we have force and time, and we need to determine velocity, so that's a hint that we should use the principle of impulse and momentum. And because we need to find the angular velocity, we're going to use principle of angular impulse and momentum. So we start with drawing the free body diagram of the wheel. So it is subjected to its own weight force. The 300 Newton force has two components. The first one is the vertical one is 300 times sine 10 degree, and that is about 52.1 Newton. And also this horizontal force, that is 300 times cosine 10 degree, 295 Newton. Also, we have the normal force right here. And because the force, this force right here, is pushing the wheel to move to the left, therefore the frictional force is in this direction to the right. If you're not sure about the direction of the friction, just think it this way. If the frictional force is actually to the left, then you do not have the couple moment in order to create this rotation. So it is because this force, frictional force, and this horizontal force, they're creating this counterclockwise couple moment, then that's what's making this wheel rolling on this ground. And also, so we have completed the free body diagram of this wheel. Also, another important information is that this wheel is rolling without slipping. Therefore, this point right here is IC, instantaneous center of zero velocity. So we are going to apply the principle of angular impulse and momentum, and we need to summarize the angular momentum about a reference point. And because we at this point we do not know what the frictional force is, therefore we should not summarize the angular momentum about point G, because this is creating angular impulse about point G. So for that reason, we're going to summarize the angular impulse about point IC, because the frictional force, the unknown frictional force, does not have moment about point IC, therefore does not have impulse about point IC. So we're going to write the equation angular impulse about point IC at the initial state plus the total moment about point IC integrated from T1 to T2 equals to angular impulse about IC in final state. So counterclockwise is positive. Initially, the wheel is at rest, therefore this equals to 0. This term right here, only this 295 Newton force has moment about point IC. All the other forces have lines of action passing through IC. Therefore, this is simply 295 multiplied by the moment arm about point IC. This is 0.5 meter. And the times the time, which is 2 seconds. So this is the total angular impulse during this time period. And on the right hand side, because this is a general plane motion and we have identified the instantaneous center of zero velocity, the angular momentum can be written as IIC omega. IIC is determined by IG plus M RGIC squared. IG is mkg squared. So this is the mkg squared plus rgic squared times omega. M is 18 kilogram, kg is 0.3 raised to the second power, RGIC is this vector right here, and this is 0.5, which is the radius of the wheel, times omega. Therefore, we have on the left hand side, this is actually 295 in the unit of Newton meter second. On the right hand side, this equals to 6.12 omega. So from here, we can easily solve for omega to be 48.2 radian per second. So you can try to solve this problem by applying equations of motion with kinematics, and you should be able to get to the same answer.